Hello. This is FASTECH. I'd like to introduce how to select motor for the direct drive Rotaty table system. The following box is an example of customer requirements. Weight is 50 kilograms, it rotates 60 degrees per 2 seconds, and acceleration-deceleration time is 0.2 seconds. The gear ratio is 1:40, and the external diameter of the table is 700 mm. To use FASTECH's motor selection guide, please access on FASTECH homepage, and put mouse pointer on the support tab. And then you can select motor selection guide, or you can click the motor guide icon below the main window. If you go to the motor selection guide screen, you can select and use 4 types of systems as follows. The current system is a direct drive rotary table system. So if you select direct drive rotary table, you will see a screen like this. If you scroll down, you will see a screen where you can enter data. There are several boxes, and you only need to enter the yellow box. Since the weight of the table and work was 50 kilograms, enter 50, and the external diameter of the table is 700 mm, and the unit of box is centimeter, so input 70. Enter 60 at the table rotation angle, and the positioning time is 2 seconds. Enter 0.2 to the acceleration-deceleration time. Next part is the external force. External force is a force that is continuously applied to the load, excluding the weight of the table and workpiece. In this example system, enter 0 for external force action angle, and radius because there is no external force. Since the gear ratio is 1:40, enter 40 for the gear ratio. In the case of gear efficiency, FASTECH's rotary table uses helical gears with parallel axes. In this case, the efficiency of the gear is up to 99, but since it is assumed that the general case, we will calculate it as 90. The safety ratio is an empirically selected value by the engineer considering uncertainties. As in the case, when there are few uncertain factors and all items can be clearly stated without error. The recommended safety ratio is 1.5 to 2, and in this example, 2 is applied. It is recommended to use a higher safety ratio if the input value contains an uncertain factor such as an external force that is difficult to calculate accurately. When you finish entering and click Calculate, the calculated result is displayed as shown on the screen. The values we need to check are the rotation speed, and operating torque of the motor at the bottom of the motor selection section. As the example was calculated, it turns out that we need to find a motor that can produce torque larger than 0.97 Nm at 222 RPM. Please click the button here to see the torque graph of the motor. Torque graphs from 20 to 86 mm size motor will be shown. Only from 60L and larger sized motors can produce torque larger than 0.97 Nm at 222 RPM. In this case, we will choose 60L sized motor, which has the smallest size among the motors which meet the condition. Please remember that the moment of inertia value at this time is 690 g/cm and the torque value is about 1.9 Nm at 222 RPM. We need to check the validity of the motor, by entering the inertia value in this box, and calculating the required torque with the motor inertia. If you enter 690 as the moment of inertia of 60L motor into the yellow box and click Calculate, the required torque value is calculated as 0.99 Nm considering the moment of inertia. Since 60L motor can produce the torque of 1.9 Nm at 222 RPM, 0.99 is an acceptable range. Finally, let's verify the validity of motor selection by calculating the moment of inertia ratio K. The moment of inertia K is the value obtained by dividing the inertia of the load by the inertia of the rotor. And if it exceeds the recommended inertia ratio, the motor may step out, stop or vibrate. Typical stepping motors allow inertia ratios from 1:5 to 1:10, whereas closed-loop stepping motors can allow inertia ratios of up to 1:30. It is not recommended to use the motor if this value exceeds 30 because it might cause problems. If the load inertia is too large and the inertia ratio exceeds 30, use a larger motor or a gearbox to reduce the inertia ratio. In this case, the inertia ratio is 27.74, so we assume that 60L size motor is suitable for the example system. On the FASTECH website www.fastech-motions.com, you can download product-related materials such as catalogs, manuals, drawings, and watch demonstration videos, and webinars. Also, if you search FASTECH on YouTube, you can see more than 100 demonstration and webinar videos. Thank you for listening.